This is Algebra 1, Lesson 9-5, Factoring by Grouping. The terrible lesson, Factoring by Grouping. It is notoriously difficult for most students, and it is reviewed again in Algebra 2 and used as a tool at a very high-level maths classes. All right, our objective today is to factor cubic polynomials with 4 terms using the grouping strategy. I think the best way to show you how to factor is to just do problems. I have 3 examples. Once we're done with these 3 examples, we are done with the notes. The general idea behind factoring by grouping, especially when we have 4 terms and it is a cubic, is to divide it into 2 pieces. I know I said a lot of things out loud, but you can actually use the factor by grouping whenever you have, if I were to ignore that term and just do it on a quadratic with 3 terms, it still is possible to use. You have to tweak it a little bit. It's actually easier to do it on something with 4 terms. And that's all I'm going to be giving you guys on your quizzes and your test is cubic polynomials with 4 terms using this strategy over and over. So I said that we're going to be dividing this problem into 2 pieces. Let me go ahead and do that. So done. Okay, so I have a piece on the left and I have a piece on the right. I'm going to ignore you on the right for a second, and I'm just going to focus on the piece on the left. So the piece on the left, I want to see what is the greatest common factor of 15x cubed and negative 9x squared. So what can we divide both of these by? Well, the first thing that pops out at me is both of them have an x. And usually you choose the lowest power, so x squared, you can say both of these can be divided by an x squared, and you'd be correct. Next, I would move on to this coefficient, 9 and 15. Well, 2 doesn't work. 3 might work, because 3 goes into 9 and 3 goes into 15. Anything bigger? 4, no. 5, yes, but no. I think 3 is the biggest we can go. So 3x squared is the greatest common factor of those first 2 terms. Let's factor it out. So if I factor out a 3x squared, I'm left over with the division problem, right? X cubed and x squared. I have 3 minus 2, so I have just 1 copy of x, which I should write in pen. X to the power of 1, which is just x, right? And then I have 15 divided by 3, which is 5. So 5x. And then I'm going to copy down the minus symbol down here. I'm going to say minus. And then x squared and x squared will cancel each other out, and I'll have 9 divided by 3, which is just 3. Okay. We're done with the first half. We factored out the greatest common factor of the first half. Now we're going to factor out the greatest common factor on the right side. So, again, ignoring everything over there, if I have a negative 20x and 12, what is the greatest common factor? What can I divide each of these by so that I factor out the greatest common factor? Well, I'm noticing that this doesn't have an x, so I can't factor out an x. Out of luck there. But I can factor out just my coefficients, my numbers. My first guess is 2, because 2 goes into 12 and 2 goes into 20. But I suspect even a bigger number could go into that. What about 4? Could 4 go into 12? Yes. 4 into 20? Yes. Could 8? No, 8 can't go in there. 10? 10, yes, but no, I think 4 is the biggest we can go. So I'm going to divide each of those by 4. So when I divide each of them by 4, I'm left with this. 4 is factored out. And then on the inside, whatever is left over, the x stays behind, right? X didn't go anywhere. And then 20, technically a negative 20 divided by 4 is a negative 5. And a 12 divided by 4 is just a positive 3. Positive 3. You'll notice here that these red marks look very similar to each other. In fact, in order to use this method of factoring by grouping, this group and this group have to be the same number. Sometimes they're not. In this case, they're not. So in order to make them the same number, I can factor out by something a little bit different. Instead of factoring out a 4, I can factor out a negative. Watch what happens if I factor out a negative. And this is always a strategy, by the way. If these terms are both opposites here and here, just factor out an additional negative. Because when you do that, if I factor out this negative right here, I'm adding a negative 4. Watch what happens. So this is a negative 4 now. And a negative divided by negative, this turns into a positive. And this positive divided by negative turns into a negative. And now this group and this group are exactly the same. That is the whole point of factoring by grouping. This next step is going to be what I imagine is the single most confusing step. And I'll talk about it right now and I'll explain why it makes sense. Let's try that. The answer to this, the final answer here is 3x squared minus 4 times 5x minus 3. That's it. It's done. And I'm hoping most of you are starting to think, what about the other one? Now, you have 5x minus 3 and another 5x minus 3. There should be 2 in your final answer. And the answer is, no, there's only 1. So why? Why is there only 1 here? And let me talk about a story. If I had 2 apples, let me try to color code this so this looks the same. If I had 2 apples, and I have another 3 apples, how many apples do I have? And you can clearly say, okay, you have 5 apples. No, you don't have 5 apples. Okay, you do have 5 apples, but you also have 2 plus 3 apples. And when you tell me this story, I say, hey, wait a second. You had 2 apples and 3 apples, so shouldn't you have 2 of these apples? Shouldn't you have another of these apples here? And the answer is no. You have 2 apples and 3 apples. You have a total of 5 apples. This is counting how many apples. This is counting how many apples. You know the final answer is just going to have apples in it. This is counting apples. This is counting apples. The final answer will just have 1 of these apples. So that's my story to try to make sense of what just happened here. I hope that it makes sense to you. But if you don't like that, you can just remember, hey, this second one that is the same, there's only going to be 1 of you at the very end. Whatever's the greatest common factor for each of these are going to be those 2 terms right here. That's always how factoring by grouping will work. Let's try another, shall we? Oh my goodness, these numbers are gigantic, but we can do it. Here we go. Again, we're going to cut this problem into 2 pieces. I prefer blue. Cut this into 2 pieces. And I'm going to ask myself, what is the greatest common factor of these left 2 pieces? And my eye is drawn to that x to the power of 3. There's an x to the power of 4. I know I can factor out an x. Typically, I can always factor out the lowest power. So x to the power of 3 is going to be factored out of each of these. Next, I move on to the harder question, 24 and 21. What is the greatest common factor? I think 2, but that doesn't go into you. What about 3? 3 is likely. If I add 2 plus 1, that's 3, so I can go into here. 2 plus 4 is 6, I can go into here. If I add their digits and their sum is divisible by 3, then the original number is also divisible by 3. So I think 3 is the answer. I might come back and change that, but I think that's good so far. So if I do that, if I factor out that 3x squared, what's left over? So x cubed and x to the power of 4 is 4 minus 3. So there's really just 1 copy of x left over. And 21 divided by 3 is 7. Seems like a good prime number. I think 3 was probably the greatest common factor then. 24 divided by 3 is really negative 24. I'll put the negative right now. 24 divided by 3 is 8, so I'm just going to say 8. And what about the x cubed? You and you match exactly, so they cancel out. Done with the first half. Okay, for the second half, I'm going to ask the same question. What is the greatest common factor of each of these 2 terms? And now each of these does have an x. So I'm going to go ahead and pull that x out and say, okay, x, and technically this is x to the power of 1 and x to the power of 1. Those were the lowest powers, therefore they are the greatest common factors. What about 105 and 120? They both end in 5 and a 0. That leads me to suspect that the answer is 5. Can I go any bigger? I might go up to 15. Here's what I know about 5. If I do 5, it's going to be wrong. And I'm going to tell you why. If I do 5, I know that 100, if this was, I'm going to pretend that 5 is not there. If this was a 0, if this 100 divided by 5, the answer would be 20, which means this answer is going to be a little bit bigger than 20. It's going to be 21. The problem with 21 is it doesn't match 7. These 2 numbers have to match. So really a better question, a little shortcut, if you will, what number will give me I'm going to put my blue parentheses because I want them to match exactly. I want this to be a 7x, and I want this to be a minus 8. I want these numbers to be the same. That's what it means to be factoring by grouping. This number and this number are the same. So 5 is clearly incorrect because 105 divided by 5 is 21 and not 7. I need to divide by an additional factor of 3, which means I really need to factor out a 15x. And I'm pretty sure that 105 can be divided by 15. I'm feeling a little bit lazy right now. If you look at the top left corner, you'll see why. It's 1:27 in the morning. I just want to use a calculator, please. Let me go to bed. So, calculator, where we go? Scientific. You can see I was doing problems for another class. Let's go ahead and clear the screen. Okay, is 105 divisible by 15? Yes. Is 120 divisible by 15? Yes. This answer I could have answered myself pretty easily by saying, well, they're all divisible by 3, because I can add up their digits. 1 plus 2 plus 0 is 3. And 1 plus 0 plus 5 is 6. Therefore, 105 is divisible by 3. If this is divisible by 3 and this is divisible by 3, I should be dividing by 3. They're both divisible by 5 as well. If they're both divisible by 3 and they're divisible by 5, they're divisible by 15. I didn't really need a calculator there, did I? All right, so I know that I got the 7x minus 8, and I know that I factored out a 15x. So one thing I didn't note in the last problem is if I don't have any number here, let's just put a plus, because it's a positive 15x that I'm factoring out. By the way, that's a 15x right there. Okay, so we use a strategy knowing I was supposed to get 7x minus 8, and we have it all ready to go. Again, if you don't like 7x minus 8, think of this as an apple. There's my apple. I don't know. It's a pumpkin. It's whatever quantity of thing that you want to count. How many of these 7x minus 8 terms do we have? Well, Mr. Sindel, we have 3x squared plus 15x of those terms. And I'm noticing right here that we forgot our very first step. And it's a mistake that I will pretend to purposely fall into. Many students will say, yes, this is the final answer. And they would get like a 3.5 out of 4. I'll give you most points. The problem is this thing can be factored even further. What we should have done as my first step is do the first step of any factoring problem, factor out the GCF. So if I were to do that correctly, I would have noticed that this term, this term, this term, and this term are all divisible by 3, because these are divisible by 3 as well. I should have factored out a 3 out of each of these, and I would have noticed that each of these has an x. I should have factored out a GCF of 3x. So I'm going to write a note off to the side of our notes. Always check GCF of all terms first. In this case, 3x was the GCF. And when I say this case, I'm referring to this case over here. So what do you do if you didn't do that? And it's okay, you can do it at the very end, but typically I make you do it at the very beginning so you don't have to keep looking for the answer. Check it out. This term right here can factor out a 3x. That was the GCF after all. Watch. I'm going to go ahead and change the color coding a little bit. I'm going to say, okay, each of these can be divided by an x, because they both have an x. Each of them can be divided by 3, so really I have a 3x. And then what's left over is a, what color do I have? Green. We can do an x plus 5. And then don't forget about our 7x minus 8 for our final answer. And let's put that all in a purple box. I'm just feeling really colorful right now. Beautiful. All right. So be careful. We fell into the trap of forgetting to factor out the greatest common factor. So we had to do it at the very end of that term. This term doesn't have any GCF, so it couldn't have been from that term. And we got our final answer. Excellent. All right, let's try our final holy moly big example. Actually, this one doesn't look that bad. Okay, I'm not falling into the same mistake as last time. I seen a 0, a 0, a 0, and a 5. I know for a fact zeros and 5s are all divisible by 5. I'm going to factor out the GCF at the very beginning this time. So I'm going to say, just choosing random color. You're dividing by 5. You're dividing by 5. You're dividing by 5. You're dividing by 5. That is the greatest common factor. So my new problem, 5 has been factored out. By the way, do you know the shortcut for dividing by 5? It's really doubling this and getting rid of a 0. Why does that work? Because when you divide by 5, what you're really saying is divide by 10 and multiply by 2. Dividing by 10 and multiplying by 2 is the same thing as dividing by 5, and dividing by 10 is reinterpreted as get rid of a 0, or move the decimal place. I'll say move decimal place. So whenever I divide by 5, I just double and move the decimal place, or get rid of a 0. So if I get rid of a 0 and double the 12, it turns into a 24. That's how you divide by 5. Oh, watch me again. Get rid of a 0, it's now a 10, and I double it, and I get 20. 20. So plus, oh, this is still x cubed, by the way. X cubed plus 20 x squared. Okay, watch me again. Divide by 5, get rid of a 0, double the 3, I get a 6. It's a minus a 6x. And this one is a little bit different because, again, you can't get rid of a 0, but I can double it first this time. 25 doubled is 50, and then get rid of the 0 at the very end, and it's just 5. Or you can just know your times table. 25 divided by 5 is indeed 5, and there is a minus sign in front of it. All right, so I did the GCF, and now I'm ready to do that two-step process where I have the line dividing right here and ask myself what each of these first two terms are divisible by. All right, the first thing that I'm noticing, I always love the variables first. X's and X's, they both have an X. Technically, they both have an X to the power of 2, X to the power of 2, because it is the lowest power. Lowest power is always the greatest common factor for your variables. What about 20 and 24? What do they have in common? Well, 2, definitely, because they mean 0 and 4, but I think maybe even bigger. I think 4, because 4 goes into 20, 4 times 5, and 4 times 6 is 24. I'm guessing it's going to be a 4. This 5 is going to haunt us the entire way down, so I'll leave the 5 out here. But I can also factor out now an additional 4x squared. When I have a 4x squared factored out, what's left over? Left over, we have 24 divided by 4, as I said before, is 6. And x cubed divided by x squared, well, 3 minus 2 is 1, and that's just x to the power of 1. What about 20x squared divided by 4x squared? Well, x squared are just canceled out because they are exactly the same, and 20 divided by 4 is 5. A positive 5 at that, so it's going to be plus 5 on the inside. All right, what about this right side? Oh, check it out. I know that it's going to be 6x plus 5. This looks really, really close to 6x plus 5. I need to get rid of a negative and get rid of a negative. Do you remember the strategy that gets rid of a negative? Because right now, I can't divide by anything. There is no greatest common factor. It's 1. But I want to get rid of the negative, so let's make it -1. If I make it a -1 and factor out a -1, then what's left over is a positive 6. Oh, I want to do it in red, though. It's a positive 6x and a positive 5. So now these groups match exactly. If these groups ever, for any reason, do not match perfectly when you're trying to do factoring by grouping, you've made a mistake. Or I have made a mistake as a teacher in making a terrible problem. Usually I'm pretty good about making good problems. Usually. I'm going to give myself a good 98%. So these terms do match up, and I want to talk about one thing that can happen to you. What if this term and this term do match? What if this was a plus 6 and plus 5, and they matched up perfectly, a plus 6 plus 5? You still have to factor out a plus 1 here. There always has to be a number here, and that's so important that I want to write it down, and I'll waste a whole line to say that. There has to be a number here, even if the number is 1. Super important, because I think the hardest question I can give you is just there isn't anything and you have to put a 1 here. All right, and I do need to end the parentheses that are over here. Okay, So what do we have now? So we still have the 5 factored out, which is haunting our problem. And now, how many copies of the 6x plus 5? How many groups of that 6x plus 5 do we have? Well, how many of these apples? We have, I'm going to write down our apples, 6x plus 5. How many of these apples? I like having it in blue. I have 4x squared minus 1 of those apples. And I can just leave that 5 now factored out, and I can just, I don't have to put parentheses, I can just leave it right there. Excellent. But wait, Billy Mays here, there's more. This thing can be factored yet again, and this can happen. I don't know how many times I do it to you guys on the homework. Let me check the answers. Wow, I gave only 2 of them. Okay, so I'm just looking at the, 4. Okay, literally half of these problems, you have to check one additional time. In the last lesson, in 9-4, we did difference of squares. Now, I expect you to know, anytime you have a square minus another square, you have to be able to factor further. And that's what I just saw right here. If I come back to my current incarnation of my notes, yes, this thing is not a difference of squares. There's a plus sign, but this has a minus sign. Anytime that there's a minus sign, I have the suspicion that this could be a difference of squares. Is 1 a square? Technically, yes, because 1 squared is 1. Is 4x squared a squared? Also, yes, because 2 squared is 4, and x squared is, or x squared. So this is a difference of squared, meaning it can be factored even further, which is annoying. I'm sure you're shaking your head at me at how much work you're having to do for one single problem, but stay with me. So I'm going to rewrite that 5, unfortunately, and I'm going to rewrite this 6x plus 5 over here, 6x plus 5, and I'm going to further factor this one as its difference of squared. Let me rewrite it in its squared form. This is 2x and a 1. This 1 is squared to give you 1. This 2x is squared to give you the 4x. That's the same exact thing, right? Which means this is going to be a conjugate pair. Difference of squares always factor as a conjugate pair from our last lesson, which means this is a 2x plus 1 and a 2x minus 1. And finally, after all of that work, so final words of warning, make sure in your final answer, be on the look for perfect squares, or sorry, a difference of squares. They're usually my additional last check, although just as a general rule of thumb in all of mathematics factoring, just check at the very end. Does anything look like it can be factored? If it's just an x, you're probably done. If there's some sort of x squared, be suspicious of that x squared. All right, that does conclude our Algebra 1 notes for 9-5, factoring by grouping. Thank you for watching.